Okay, and then you have 30, 60, 90 triangles. You can tell the difference because they have to say 45 and one has to say 30 or 60. Okay, so 45 has to have 45s, 30, 60, 90 have to have 30, 60, 90. So what we're going to do is we're going to do the 45, 45, 90 first. So we're using this formula. So on your little triangle, what we're going to do on the outside, this is represents X. It's a length. Whatever that length is also will go here. And then those numbers, whatever that number is, because it's going to go there and there, also goes here as X, but there's another piece to it. It's not just X, because using your eyeballs, you could tell that this is longer than these. So this is X, and then we stick a square root of 2 on the back. You are not using a calculator. We are not putting a decimal, okay? It's literally X, so some number, square roots of 2. Okay, so the legs are X, your hypotenuse is X square roots of 2. So it's like a little puzzle. We're just kind of moving around numbers. You should not be using a calculator. You don't need a calculator for this. Okay, so we're not taking the square root of anything. So for numero uno, first thing we're going to do, this is spinning the triangles like around it, like rotate it a little bit. So I'm going to put the formula inside the triangle. So there's an X here. There's an X here because those sides are the same. And then I have X square roots of 2 there. So that's just the formula. So there's a number that I can use. There's an 8. If 8 is X, where else can 8 go? X, the other side, right? Okay, so those both match because they're both the same distance. So if this side's 8, that side's automatically 8. Does anybody want to take a wild guess at what the hypotenuse is going to be? Oh my gosh, 8 square roots of 2. And that's it. Boom, you're done. So X is technically 8. The length of Y is 8 square roots of 2. So number 2. Okay, number 2. It's still a 45, 45, 90. So I'm going to put the rules. This is X and this is X because they're both the same length. The hypotenuse is X square roots of 2. So where else can 25 go? Y. What's the hypotenuse going to be? 25 square roots of 2. And that's it. How do we feel? Easy? Yeah. Weird? Random? Yeah. Okay, let's keep moving. Shh. For number 3, we're going to do the same thing. We're going to write the equation on the inside. It's going to be different this time. So X is going to go here. X goes here. X square roots of 2 goes there. So notice last time I was given X. X was just the number, and then I just kind of stuck it together. Now this is what I'm given. I know the ugly piece. So this is where it gets a little tricky. We have to solve this. So we're going to say X square roots of 2 equals to that length. That length is 19. From algebra 1, we need to get X by itself. So this is X times the square root of 2. So how am I going to get rid of the square root of 2? Divide. So we're going to divide by the square root of 2 to both sides. Just like normal, how it like crosses out. These ones cross out. So I have X equals, and I cannot leave it as 19 over the square root of 2. This is the tricky part. You cannot leave a radical in the denominator of a fraction. So it's called rationalizing the denominator. So in algebra 1, you should have removed a radical from the denominator. Does anybody remember from algebra 1 how to do that? Of course not. So what we're going to do is we're going to multiply by the square root of 2. So we're basically multiplying by the denominator to remove the denominator. So I multiply by the square root of 2, multiply by the square root of 2. So 19 times the square root of 2 is just 19 square root of 2. And then the square root of 2 times the square root of 2 is the square root of what? 4. And what's the square root of 4? 2. And that's my answer. So I solved for X. X is both of these sides. So this side is 19 square roots of 2 over 2. And this is 19 square roots of 2 over 2. And you're like, what in the world are we doing? You should have did radicals in algebra 1. Operations with radicals, but you probably don't remember it because it's very random. So both answers are 19 squared is 2 over 2. Yes, it's gonna be like that all the time.
Oh, jeez.
Okay, so, now you don't have to. It's fine. Because 19 divided by 2, does that even go even? Am I crazy? Yeah, you don't, it's not good. Okay, let's do 30, 60, 90s. Shh. I'll be quiet. Okay, 30, 60, 90 is the other rule. So on your blue sheet, 30, 60, 90 is the other one. This is very similar. Ooh. Okay, but you have 30 degrees, 60 degrees, and 90 degrees. X is the base, so that's the shortest side. Your hypotenuse is the longest side, which is going to be 2 times X. Stop talking, or you guys are going to have to sit separate. Stop it. And then X square roots of 3. So over here, let's put X, 2X, and X square roots of 3. So my short leg is X, my longer leg is X square roots of 3, and then the hypotenuse, which is the diagonal, is 2X. Thanks. Okay, for number 4, we're going to start by putting the formula inside the triangle because it's just going to help you. So we're going to put an X here, we're going to put a 2X here, and we're going to put an X square roots of 3 here. So I'm given 5. 5 is X. So how much is my hypotenuse? 10, because it's 2X. So if this is 5, this is 10, how much is going to be the height of your triangle? Not 10 to the square root of 3. 5 square roots of 3. Boom. Because this is your X, and that's what you're just putting in front of it. So 5 square roots of 3. Your hypotenuse was double, so it's 10. So try number 5. Start by putting your formula inside your triangle. This one's easy. You're not doing any like rationalizing denominators. You're just moving the numbers around. Yep. So the hypotenuse will always be multiplied by 2. Huh? Yeah. Okay, so if this is X, what's my hypotenuse going to be? 28, because I double it. And then this is X squared to 3, X is 14, so what's this length? 14 squared to 3. Not too bad. It's like super weird. It's very random. It's like a puzzle. It's just moving numbers around. It's Akko Taco. Okay, so let's do number 6. Number 6, same thing. I'm going to start by just putting the formula inside the triangle. So X is your shortest side. Your hypotenuse, the diagonal, is 2X. The height of the triangle is X square roots of 3. So this one's a little bit different because this time I'm given the hypotenuse. The hypotenuse is 32, which is really 2X. So we're going to divide by 2. So how much is the base of the triangle? 16. And then what's going to be your height of your triangle? 16 square roots of 3. So try number 7. Number 6 is just like number 7. Okay, so if you're given the hypotenuse is 46. So what's my base? 23, because I had to cut it in half. And then what's my height? 23 square root of 3. Is that what we got? Yeah. Me. Okay. Let's keep it moving. So this is where it gets a little ugly. So let's label the inside of our triangle just like we've been doing. The shortest side is x. The hypotenuse is 2x. So for all the other problems, I was either given x or 2x. This time I'm given x square roots of 3. So if I'm given the thing that's equal to the square root, this is where red flag, it's going to be like annoying. Okay. I'm going to take these two and I'm equaling them to each other just like I did with the 45, 45, and 90. So because I have to solve for x, so I have to get rid of that radical. So over here, I'll do x square roots of 3 equals, and what am I equaling it to? 20, because that height is 20. My goal is I need to isolate the x. So just like when we did 45, 45, 90, last time it was the square root of 2. What am I dividing by now? Square root of 3. I'm going to divide by the square root of 3. It crosses out on this side. Divide by the square root of 3 over here. I can't leave a radical in the denominator. Any math class you take, you just can't leave it. It's irrational. Yes. So I'm multiplying by the square root of 3, multiplying by the square root of 3 to get rid of the radical in the denominator. So these just get stuck together. So I'm going to have x equals 20 square roots of 3. And then in the denominator, really the square root of 3 times the square root of 3 is the square root of 9. Square root of 9 is 3. That's why the radical goes away. Or you can just remember it's just the number that's under the radical. So technically, what value is that on my triangle? That's y. So that's the base. So right here is 20 square roots of 3 over 3. Okay. My hypotenuse is technically double that. So if it was 20 square roots of 3 over 3, does anybody think they know what it's going to be now? 40 square roots of 3 over 3. So the only thing that actually changes is that front number. The denominator stays the same and the square root stays the same. Square root's kind of like an x. It's like a variable, just chills out, hangs out. And then your denominator stays the same because it's really like you're multiplying by 2 over 1. And so the denominator multiplies with 1, so it doesn't change. Or just remember the front number just changes. So x in this case is 40 square roots of 3 over 3. And then 20 square roots of 3. Now that we've done like a couple of the radical problems, does anybody remember doing this in or like in math? Yeah, it's always gonna be like that. Yep, literally. Yeah. And then technically you could, if this was possible to reduce like 40 divided by 3, you could reduce it, but 40 doesn't go into 3. Like 3 doesn't go to 40 evenly, so we just leave it. So let's try number 9. Same thing. Start by labeling the inside. See if you can try to set it up. Yes. 7 a typo. Like on the back or the front? Oh. Oh, you're not doing something. There's certain ones that you're gonna do. Hold on. Okay, so what am I setting it equal to? What am I doing? Anybody? Okay, so let's set these equal to each other. So I have x square roots of 3 equals 9 square roots of 3, which is like, that kind of looks similar. It is just 9. The reason why it's just 9 is because if you divide by the square root of 3, and you divide by the square root of 3, what happens to the square root of 3 on both sides? They cancel. So x is just 9. So if this is 9, then what's the hypotenuse? 18. If you don't realize that they match, I'll show you this, but I might confuse you. But if you don't realize that they match and then you're like just rationalizing the denominator, you're like, I'm gonna multiply by 3, I'm gonna multiply by 3. You could do this, okay? 3 times 3, these would actually multiply together to make it like you have still 9 in the front. Square root 3 times 3 is 9, just like in the denominator, technically 3 times 3 is 9, third of 9. You could simplify both of those, just like the denominator just becomes 3. This becomes 3 times 9, that's square root of 9 is 3, that's 27. 27 divided by 3 is 9. Or they cross out, so it's just 9. But that's why they cross out. But that might be too much math for your small brains. Yes, we are crossing out a lot on the back. Okay, let's go to the back. So on the back, you are not doing all of this. First off, this is a very weird, just random thing. We're starting trigonometry when we get back from spring break. So this is like an intro to trig. So this, you're gonna do 1 through 6. You're gonna do number 8. The rest you're crossing out. So you can cross out 7, you can cross out 9, 10, 11, 12, 13, and 14. This is a very random thing. It's usually not on the EOC. It's just kind of like a random little puzzle, like that they're like, do you know how to use this formula or not? So they never put it on there. Okay. Could it be on there? Yes. Is it fair game? Yes. Is it ever on there? No. So you're doing those problems. Okay. I'm gonna come around. I'm gonna pass out whatever random papers I have. I feel like I did that yesterday, but I'm gonna pass out whatever I have anyways. And then make sure your binder's in order. If I get it today, that's fine. If I get your binder tomorrow, that's okay. Tomorrow and Friday are cycle 3. So